In summer homework problem number 35, we're supposed to be graphing a line that is not in slope-intercept form. There's more than one way to do this, but today I'm going to be showing you how to do it by first changing it into slope-intercept form. We know something's in slope-intercept form when it's y equals mx plus b, which means we want to isolate y. We want to get y by itself. So what we're going to do is we're going to solve for y. We're going to take this equation, rewrite it, and solve to get y by itself. The first thing we're going to do is move the x term to the other side. We do that by subtracting 3x on both sides. We're left over with negative 2y, and we usually rewrite this to have the x term come first. It'll be negative 3x plus 6. They aren't like terms, they don't combine. The last thing we need to do is divide by negative 2 to get y by itself. So we divide everything by negative 2. We get y equals, here we can't divide 3 divided by 2 evenly, but what we can notice is that it's a negative divided by a negative, which makes it a positive. So we're gonna leave it as 3 divided by 2, but it'll now be a positive, so 3 halves x. The 6 can be divided by negative 2. A positive divided by a negative is a negative. 6 divided by 2 is 3. And notice that dividing distributes across an addition sign just like multiplying does. Once we have it in slope-intercept form, the slope is the number in front of the x, and the y-intercept is the number in front of that doesn't have an x term, the constant term. And so we notice this is in y equals mx plus b form, where m is the slope and b is the y-intercept. So since negative 3 is the y-intercept, the function will cross the y-axis at negative 3, y equals negative 3. The slope is 3 over 2, which means that the function will go up by 3 and over by 2, up by 3 and over by 2, up by 3 and over by 2, up by 3 and over by 2. It also goes back down by 3 and left by 2. When we graph a function, we need to make sure we put arrows on the end because it keeps going infinitely.